So now you can balance equations. It's time to cast our minds back to something that you last saw halfway through last semester, the roadmap. If you remember, the roadmap was a way in which we related an extremely important concept in chemistry, moles, to a myriad of things. First thing we related it to was just taking the definition of a mole. 1 mole is 6.02 times 10 to the 23 somethings. And so if we have 1 mole of, say, water, that means we have 6.02 times 10 to the 23 water particles or molecules. If we had 2 moles of sodium, that would be 2 times 6.02 times 10 to the 23 sodium atoms, and so on and so on. Now, of course, the reason we use a silly number like 6.02 times 10 to the 23 is that 1 mole of a substance weighs its relative mass in grams. And so if you've got number of grams of a pure substance and you know its formula, you just look at that formula, take the mass of each atom from the periodic table, add them all up, and that gives you the molar mass in grams. And so you can just take the grams is equal to that molar mass times the number of moles. Now, what's on the screen here is an extremely powerful set of relationships because it enables us to weigh out a certain amount of a pure substance, convert that to moles using the molar mass, and then from those moles count effectively how many molecules or atoms there are in that sample. It relates the macroscopic, the measurable scale, to the submicroscopic, the atomic or the molecular scale. And then a little bit after that, we said, well, a lot of times you haven't got the pure substance. It might be in a mixture. And of course, in chemistry, the most common mixture is a solution. And so we can measure out the volume of a solution, and as long as we know its molarity, we can convert that measurable, that volume, into the number of moles. Then a little bit before the solution, although I didn't relate this directly to the roadmap, but I trust you can remember it and do so now, we said, well, sometimes your pure substance isn't a solid or a liquid, it's a gas. And the trouble with gases is that they're really not very dense at all. And so a small volume has a really teeny mass. So what we'll typically do with gases is we won't weigh them out, but we will determine their volume at a particular pressure and temperature. And using the ideal gas law, PV equals nRT, we can relate the pressure, the volume, and the gas to the number of moles. So we ended last term with a way in which we could measure amounts of a substance, its grams, or the volume of a solution, or the volume, pressure, and temperature for gas, relate that to moles, and from the moles go down to that atomic or molecular level, the number of particles. Now, of course, this term, in just that first video, we can expand the roadmap, because now we can say, well, if we've got a chemical reaction and we know the number of moles of a substance A, we can relate that to the number of moles of a different substance B, just using the coefficients in the balanced chemical equation. And so now in our roadmap, we've got moles of one substance on the A side and moles of another substance on the B side. And that enables us now to relate not just grams, particles, pressure, volume, temperature, and litres of solution of substance A, but every box that we got on the A side will have a corresponding box on the B side. What I mean by that is that this box here is not just number of particles, but it's the number of particles of A because it relates to the moles of substance A. And so there'll be a corresponding box on the B side that relates the moles of substance B to the number of particles of substance B. We have a gram box on the A side that now obviously refers to grams of substance A. Well, once we have moles of B, we can relate it to grams of substance B. And we can expand out the roadmap for the other boxes. So instead of now this just being litres of solution, it's litres of a solution of A, and we have the corresponding litres of solution B. And now if substance B exists as a gas, we can of course talk about the pressure, volume, and temperature of that gas of substance B and relate it to the number of moles. So now we have an extremely powerful set of relationships here in which we can study a chemical reaction that in some way relates substance A to substance B, and it doesn't really matter what substance A is made up of. If it's a nice easily weighed pure substance, we can get grams. If it's in solution, we can do liters. If it's a gas, we can get its pressure, volume and temperature, relate that to B, and again B, it doesn't matter what phase it's in, we can weigh it, we can measure the volume of solution, or we can determine the pressure, volume and temperature of a gas. So an extremely powerful little picture here that we're going to use, hopefully, from about halfway through the first class of this week all the way through the second class of this week. By the end of this first week of classes, I want you to be absolute world experts at using this roadmap.